tools that we have for secure communication among activists, journalists, and human rights defenders. Sarah Aoun and Josh King are our presenters of Signalbots, Secrets Distribution and Social Graph Protection for Activists. Sarah Aoun is the chief technologist of the Open Technology Fund. Josh King is a co-founder of Throneless Tech, a DC-based tech worker cooperative. We're going to start off with a presentation, and then afterwards we will have questions. And as a reminder, the only way you can ask is to do it through the Matrix chat. Look up the live stream session Q&A channel.
My name is Josh King. I'm a software developer and co-founder at Throneless Tech, an activist-focused technology worker cooperative based in Washington, D.C. Over the past 14 years or so, I've been focused on technology projects around internet freedom and community technology, providing support for activists, human rights defenders, and independent journalists around the world.
Hi, I'm Sarah. I'm the Chief Technologist at the Open Tech Fund, or OTF for short. Most people haven't really heard about OTF, but you've definitely heard of the technologies that OTF funds and supports, such as Tor, Signal, WireGuard, Tails, and a lot more of them. OTF is kind of like a tech incubator for open and accessible technologies that promote human rights and open access to the internet. We work with technologists, with human rights defenders, with journalists, with activists, with NGOs, and really anyone experiencing restricted access to the internet. And while we mostly fund tools and research and projects, we also offer different types of services. We localize tools in different languages, we conduct security audits, we offer UX and UI support. And in dealing with all these different contexts and the folks in all these different contexts, we're always thinking and weighing the different types of circumvention technologies for people that live in places where internet freedom is restricted and actively repressed in the form of network censorship or digital security threats. And as a funder, OTF is in kind of a unique position. We have the ability to engage with commercial VPN providers to subsidize access and service for journalists, for activists, for free expression defenders, really anywhere in the world. So we all know that VPNs don't provide anonymity. There have been enough horror stories out there of logs getting leaked or ending up on the internet, and that's not really what we're trying to solve for. It's just that we often work with people in regions where content is blocked, and getting access to some sites is only possible through circumvention technology. And sometimes that means using Tor, and then other times that means using a VPN. So in thinking about this and wanting to provide this type of service, clearly going around and handing out codes one by one to people is not really a viable option. So it got us thinking, how can we facilitate this process? How can we create a system of distribution that's safe, that's private, and that's secure? And why should we even do this at all as OTF? And in thinking about this VPN question, it also got us to take a step back and think about a broader issue here. We work with very sensitive groups. So how do we create a dissemination tool that solves for this activist social graph problem? How do we create a dissemination tool that essentially protects and keeps the information safe for all these people that we work with?
Signal is one of the best tools that we currently have for secure communication online, not just because of how secure it is, but also because of its wide adoption. It is an obvious move to see what other ways that we could utilize Signal to provide other kinds of services to people without having to require them to install yet another app. So with OTF's help, we created a project called Ionosphere, named after the layer in Earth's atmosphere off of which you can bounce signals, in order to provide essentially a chatbot or other text services that would operate over Signal to be able to provide different kinds of information to people. The initial use case for this that we sort of focused on was what we've been calling the activist social graph problem. So Signal groups are great. They're super secure. They're great for keeping up with people for organizing and everything. But probably the most common complaint, I would guess, about Signal is that it requires your account to be tied to a phone number. And that's the same with Signal groups, where everyone in a group has everyone else's phone number. Now, there are very clear reasons why Signal designed it this way, but you can see a use case where, say you're using a Signal group for organizing, you're organizing a protest and you're at a protest or rally, and someone in the group's phone gets stolen or confiscated, or some other way a bad actor gets their hands on it, and then that bad actor is able to see the phone numbers of every other person in that group that is connected with this person doing this organizing work. So the idea that we had was to create an intermediary, a bot that could be controlled by an organizer or whoever is operating the bot, that could essentially be sent a message, and then that bot redistributes that message to every other member in the equivalent of a group. We were calling a list or whatever. That the bot receives a message from an administrator, and then the bot sends that message one-to-one to every other user that the bot internally knows is supposed to receive this message. And then if someone on that list, if their phone gets confiscated or stolen or whatever, that then that user only has the number for the bot, and that number can be a throwaway Google Voice or Twilio number that isn't necessarily as easily connected to every single other person who might be receiving those messages that provide warnings and notifications and whatever else to people at that protest, as it would be if it was a Signal group with everybody's individual phone numbers in it. And so how did we go about creating this thing? Well, Ionosphere is made up of a few different components. First of all is a JavaScript library for interacting with the Signal service. Signal already publishes a JavaScript library that's open source, but that library only covers the wire protocol and not actually all of the things that you need in order to interact with Signal's own servers and services themselves. So we created a port of the JavaScript library in Signal Desktop to Node.js so that we could use that in order to build a chatbot. Why didn't we use the existing Java libraries for doing that? Well, basically, if we were going to build this, we had two options as far as existing implementations, Java and JavaScript. And the Java libraries already existed, but we want to, as a secondary goal, create opportunities for other developers to be able to use this to build cool things on top of Signal and other use cases that we wouldn't necessarily be able to think of. And there's no more widespread programming language in the world than JavaScript. So we decided to take the library components, extract them from Signal Desktop, build new APIs around them, create code examples, documentation, get it security audited, all of those things, so that so it wouldn't be used just for Ionosphere, but so that other software developers could use it for their projects. Secondly, we use that library to build an adapter for a common chatbot framework, Qbot. Qbot's a chatbot framework written in JavaScript that was originally created by GitHub, and it's one of the more commonly known and most popular chatbot frameworks in the world. And one of the reasons, likewise, for selecting that was to leverage that sort of ecosystem, make it easy for developers to use something they were familiar with, to create things over Signal, and also so that we could use anything that anyone had created for Qbot and just immediately use those different kinds of scripts and plugins and things over Signal. Also, then we created our own Signal plugins in order to provide the functionality for like the distribution lists and any other things that we could think of. Building off of that, an obvious choice was, now that we knew how to distribute messages in secret over Signal to a large group of people, was using it to distribute other kinds of information. And so we built Qbot token, which is a script for being able to provide for users to be able to request different kinds of tokens and secrets and other access stuff, particularly VPN codes in this case, over Signal, so that a user would be able to request like a certain number of VPN codes or other secrets, and then that would get approved by an administrator, and then that list of codes would be sent to them over Signal. So what are some of the security ramifications of running this kind of framework for being able to provide text services over Signal? Well, one advantage is that over having something like a Signal group is that because the bot can be tied to a throwaway phone number, and really other than maintaining ownership of that phone number so that it can't be appropriated by some other Signal user, whether by malicious intent or accidentally, beyond that, retaining ownership for those reasons, after that initial registration against the Signal server, the bot doesn't even really need to receive messages or have any connection to the phone system or anything like that. It only needs to be able to connect to Signal servers. So the bot can essentially run anywhere. It can run over Tor or wherever. And because without the addition of like other sorts of things like web interfaces and other stuff, all interaction with the bot happens over Signal, it has very, very little attack surface. And so you don't need any particular hosting. You don't need like a publicly exposed IP address in order to be able to run this service. It just needs to be able to connect to Signal, and you need to have a phone number in order to set it up in the first place. It is probably a good idea to maintain ownership of that phone number so that you aren't suffering from the equivalent of SIM jacking by having someone else take that phone number and then re-register it, although everyone would see the safety numbers for the bot change for them. So you could have procedures in place to be able to anticipate that eventuality. But other than that, you have the advantage that the bot can be running essentially anywhere and not publicly exposed to the internet. Now, there's a very obvious reason that Signal doesn't provide these kinds of services, which is that the bot is inescapably a person in the middle. And so the messages that someone might be sending through this kind of relay are going to pass at some point in plain text through the bot. And so whoever has access to the bot or is running it, at least potentially has access to these messages. It's kind of at least so far, somewhat inescapable consequence of running this kind of like relay infrastructure. It's the equivalent of like sending a Signal message to someone, a friend of yours, and them like copying, pasting it, or typing it into the chat box to another Signal user that they are familiar with. And so the bot is only as trusted as the people operating it. So it's pretty obvious why Signal doesn't provide this sort of service when they want to make sure that their service their servers know as little about the users who are sending messages through it as possible, and as little about the contents of those messages as possible. That said, for all of the reasons that we've outlined, you can see some use cases where a trusted group of people might want to make use of this kind of service, or that they might want to provide a service over Signal that doesn't require any sort of like additional trust, like informational services and things like that, they might choose to decide that it's low enough risk that they trust the operator of the bot. And so we saw as still a service that was worthwhile in like designing and building and providing, so that people could choose to run this kind of service for folks that they were interested in providing trusted services for.
Okay, so back to OTF. Why do this at all? Why think about VPN services in the first place? One, a lot of folks on the front lines don't really need the full anonymity that Tor provides. Two, VPNs are complicated, and we know that from the dozens and dozens of guides that you can find on the internet about how to choose a VPN and how to set one up. And a lot of the folks on the ground don't really know which VPN providers to trust in the first place. And 3, in some countries, figuring out online payments to a VPN provider can actually be a very complicated process or not even possible in the first place. So in thinking about all these things and about this VPN bot, how can we essentially put up the system in a way that is safe and secure? And in thinking about it, we were really inspired by the Get Tor project, which is a service that provides alternative methods to download the Tor browser, especially for people who live in places with a high level of censorship and where accessing the Tor website is blocked or just restricted. So this is where a VPN bot comes in. And in thinking about it and sketching it out, the MVP looked essentially like this. We would have 3 types of users: an admin, a manager, and a recipient. An admin would be able to deploy VPN codes to recipients or to managers. A manager would be essentially a trusted member of our community, someone that OTF has worked with a lot, someone that we trust and that we know has a wide network and is able to disseminate codes to a bunch of recipients if needed. And a recipient would be able to request codes from a manager or from an admin to then be approved by those folks and deployed. So the bot would be able to answer to a certain set of commands, and that can be adapted as you need depending on the project that you're working on. So in our case, an admin would be able to add managers, remove managers, check on the status of codes that are still available, deploy codes to a recipient, create buckets of codes to be deployed in bulk. A manager in their case, can mostly do the same thing and also deploy VPN codes and choose from, say, one provider or another VPN provider. And then a recipient would be able to request codes, as I said, from the bot. They could, say, request 1 code or up to 20 codes. They could request codes for a 1-year service or a month-long service. So say you're a security trainer and you're giving a security workshop somewhere and you're teaching people how to use a VPN, then say in a situation like this, requesting 10 codes for a month-long service would be ideal. So we were guided by the following principles. Safe. We're trying to help people, at the end of the day, under heavy censorship and security threats. Reachable. A user has to be able to engage the bot even in a heavily censored network. Easy to use. The fewer user interactions exist, the better. Clean code. It should be able for other developers and contributors to work on this bot and to see how it can be improved. Multilingual. It has to be able to support different languages for different people in different contexts. Provider agnostic. The VPN bot should be able to support different VPN providers. Private. Admins should have no visibility at all or the ability to engage with recipients directly. We assume that recipients don't have and shouldn't trust OTF. We don't want to know who they are, and they don't want us to know who they are. The bot is incredibly versatile and could be adapted and evolved to anything, really. At this point, for OTF, we receive a list of VPN codes from a provider, and then the bot would essentially ping that list to distribute codes to whoever is requesting them. But in thinking further, the bot can also be used to deploy configuration files for standalone VPN servers or other types of cloud services like Heroku or Greenhost. Sometimes groups that we work with need to host their content on an encrypted server or to deploy standalone VPN servers, but sometimes don't have the capacity in-house to do something like that. So OTF would offer these services and then would distribute the credentials to the person then who will maintain the server after the initial deployment. So you can imagine how that would work. And so this bot, you could take it and essentially adapt it to your needs as necessary.
Now we're going to show a quick tech demo of the Signal bot in action, sending messages to a list of users. We're skipping over the setting up of HuBot, but you can find instructions on how to set up HuBot in the Threadless Tech GitHub repo at github.com/threadlesstech/Ionosphere. Now, we're setting up HuBot with a few plugins. For the purposes of the demo, we're using a simple plugin for storing the state for the bot and the encryption keys in just a JSON file in the bot's directory. We're defining the number that the Signalbot is using in order to communicate with the users. We're setting a particular number as an admin that is capable of administering the bot. And we are specifically defining the adapter that the bot is using as the one that connects it to Signal itself. So we just run this, and then on first run, the bot has it send a verification code to the number that you defined as the bot number. And then once you receive that code, you can start the bot again, defining that code on the command line, and that continues with the verification process. So we received the code 444437. And so then we're just going to go back and run HuBot again. We'll define that verification code. After you run it this time, it will generate all the keys and register it with the servers. You don't need to keep specifying the code if you don't want to in future things, and it runs the server. Now we're going over to two different instances of Signal that are already set up to communicate with the bot we just set up previously. The one on the left is the admin user that we defined before. The one on the right is just a regular user that the bot doesn't know anything about. And we can see that each of these users is able to ping the bot, and it replies. So they're both able to communicate with the bot. Now, the admin user is going to create a list of users to distribute messages to. And then they can add any number of users to that list that they want to send messages to. In this case, we're just using the one number of the demo user on the right. Now they're added to the list, and we can easily send messages to any number of users on this list. And for the purposes of VPN codes, the bot is also capable of keeping track of not just lists of users, but lists of codes, and then distributing sets of codes to any list that we define.
So we worked with Simply Secure and CADE at New Design Congress to do UX and UI design for users and folks interacting with the bot, to think essentially about the easiest way to use the bot and the most flexible workflow across different use cases and different languages. So an important part of doing this work, other than just thinking about the UX UI, is thinking about risk assessment. What are the different risks involved with this project and with this bot specifically? What are the different attack surfaces, and what information can be exposed? How can we put people in danger in essentially doing this work? One example, for instance, is the issue around phone numbers. In thinking about the different users that we have that interact with the bot, we have an admin that's essentially in charge of the entire platform and can add managers. Then we have managers that are essentially trusted nodes in our network, folks that have worked with OTF, folks that we know and that we trust essentially to be that person in the middle. And then we have recipients. So for the managers specifically, in interacting with them and having them interact with the bot, we would recognize them essentially based on their phone number. But then how do we account for folks that have different phone numbers and could be texting from say a burner number? How do we account for the fact that some of these phone numbers are actually quite sensitive? Do we save this information somewhere? Do we store it in an external spreadsheet? How do we store this information? And then the second issue here is, what if this phone number is leaked? What happens when someone goes after this trusted phone list of essentially all these managers who are essentially, all the different network nodes in OTF's network? How do we remove this dependency on this phone list or on this external spreadsheet, and how do we reduce the attack surface there? Another issue that we thought of is account bombing. How do we plan for that? How do we deal with situations in which the bot is actually overloaded? What if the bot is receiving incessant requests for VPN codes? How do we limit maybe that rate? Is it possible to break the VPN bot by requesting codes over and over again? How do we account for situations like this, and how do we essentially plan for a potential DDoS attack against our VPN bot? There are lots of considerations to take into account when thinking about this bot and thinking specifically about the types of users it's supposed to serve. And creating technology is relatively easy, but creating technology for high sensitive groups, human rights defenders, activists, journalists, lawyers, is really incredibly challenging, because whatever you do and whatever you create, it has to be done with not putting people in more danger or unnecessary danger. And in some cases, technology is not the solution at all, and that's important to recognize at some point. If anyone is ever in the position of creating technology or building technology for activism, it is important to know when to walk away from a project, or to recognize that this technology is not solving the problem that's at hand and is not really serving the purpose that it was supposed to serve. The VPN bot is up and running, it's ready to use. We're testing it out with different groups. If anyone has any thoughts about it, would love to hear more. Once again, I'm Sarah, I'm the Chief Technologist at OTF. Thank you for listening to this talk, and looking forward to your questions.
Thank you for attending our session. Thank you to the HOPE organizers for accepting our session proposal and allowing us to do this talk. Thank you to the Open Technology Fund for funding this work, and to Signal for creating such a great service and app for us to build these technologies on top of. Again, my name is Josh King. I work at Throneless Tech, which you can find online at throneless.tech. All of the code for the projects that we outlined in this talk is available open source on our GitHub, and thank you for taking your time.
And we're back with Josh King and Sarah Aoun. So we have demos set up to show how this works.
Yeah, so we have an instance of the bot that we were just talking about in the video set up. You can hopefully see the number at the top, so you can try it out as well. If you want, it'll be online for the rest of the session and a little bit after that. Please don't abuse it or anything like that. It's set up so that anyone who messages it is an admin, so that you can try out like all the features. First of all, we can see if you ask for help, you can see like a large number of commands that are available for this bot. This particular instance is set up with the plugins for creating and managing lists of users for distributing messages to, and also creating and managing collections of VPN tokens to be able to distribute to different users in those lists. The style of the commands and everything in this version, if you saw the sort of flow chart in the video, that's kind of part of a process that we're undergoing to kind of turn this from was currently sort of like an internally focused sort of tool for trusted users to be able to use this to distribute tokens, to more of a to something that has more of a user-facing kind of element, or a self-service kind of element, and has more of a natural language kind of style to the commands. So we can see, well, we can show right away like the lists that we have available. We've got admins, and we also have recipients. We can create additional lists of users. Let's create one for Hope, and we're going to add a number to this. All the numbers, if you try out the bot, all the numbers are in the E164 format, so +, country code, and then the full phone number without any spaces or dashes is kind of the format that Signal expects numbers to be in, and we sort of adhere to that. So the not using any real numbers, but if you mess with the bot and add like your phone number to one of the lists, just be aware that that phone number would show up to anyone else who uses the bot and like dumps the list. So just, FYI. We can, you can also add a list of numbers all at once by doing list add, the name of the list, and then space separated like multiple phone numbers. And then if we want to send, obviously this wouldn't work because this isn't like a real phone number, but if this was like a real phone number or a list of phone numbers, we just have to do @ in the name of the list, and then whatever we want to say to that list, and then they receive a message from the bot with a prefix indicating whether or not, like indicating the list that this is coming from, including the including the message that you send to the list. That option for like whether to prefix the name of the list is configurable. We also have token buckets. So right now we just have one token bucket. That's just kind of the sort of name that we've used because token buckets are a thing, but it's the name that we've used to like for the sort of collection of a given set of tokens. The tokens can have like are relatively arbitrary. They include fields for code, like whatever the string that the token actually is, value, which is an arbitrary also an arbitrary value, but might be useful if you are getting issued, say, like a VPN code that's useful for a certain number of days or a certain amount of time. It's useful to be able to assign a value to each of the codes so that when they get issued, you're able to see like, oh, this is worth whatever, 60 days or whatever the person who loaded that code into the system assigned to it. They can also have an expiration date, and you can see where it shows total, issued, expired, so that if tokens expire at a certain time, the bot can automatically expire those out of the bucket that that they're using. We can create new buckets, and tokens are generally loaded into the buckets by this is using a functionality of the library where we can actually use like file attachments. Hopefully I'm remembering the syntax correctly off the top of my head. So that was the CSV file that just includes like a bunch of, it's just mock data as the file name might suggest. They aren't real like VPN codes. They're just a bunch of UUIDs. But now now we have 500 tokens in that. See, I already forgot, like, all right, token show buckets. So now we have 500 tokens in that particular bucket. It also keeps track of deduplicating tokens based on the whether or not the particular code was already loaded into this token bucket previously. This is useful because previously VPN codes for this particular project by OTF were managed entirely in like basically spreadsheets, and so it was important to be able to automatically consolidate those spreadsheets across different things to make sure that there weren't any duplicates. There isn't I didn't include a way to directly view the tokens from kind of like an admin level, like print out all 500 tokens, because that wasn't really, it didn't feel particularly useful for anyone but the individual person that is actually receiving the token to actually be able to see what the code is. But then you can say issue 10 tokens from a given bucket to recipients, and it will send out that number of, or to a particular number. We're not saying response because that's not a real number that's in there, but the recipient receives a message with a list of tokens that that they have been issued, saying like, hello, you've been issued this number of tokens. They have this value. Here are all of the tokens. You're also able to issue tokens that have a particular amount of value. And we also, if we look at the command help again, you can see that we've got some, we have some special functionality for some VPN services. So currently we only support Mulvad, but the bot is actually set up so that we can assign a bucket to either be a set of Mulvad accounts, like codes for setting up accounts on the Mulvad VPN service, or codes that are for value that can be assigned to a particular account. So this uses an API that Mulvad exposes for being able to create accounts and assign value to those accounts. So you're able to use this to say, create a list of free accounts, be able to issue an account to somebody, and then go back and be able to re-up their accounts by saying, hey, I want to apply, I have a bucket of Mulvad codes. I created it at, when I created the bucket, I said it was a Mulvad codes bucket. I want to assign a code to this user to their account. If that user has multiple Mulvad accounts, then the bot will come back and ask you, hey, like this user has multiple Mulvad accounts, select from this list of accounts and which one you want to be able to assign value to. So this is like a valuable administrative tool for like being able to sort of manage this this program. And if they're Mulvad VPN accounts, then it doesn't even require any user interaction other than like accepting codes that are issued. But more value can be added to someone's account directly from the bot without them having to then go and load up a website and go and enter this code into Mulvad system. We want to add support for additional VPNs, you know, that are used by this this project of OTF when it gets unsuspended, and the and so that basically just depends upon available time and also what kinds of API endpoints are exposed by the different VPN providers. But Mulvad's been very helpful with like setting up those VPN endpoints, those API endpoints for us. So this bot is, like I said, it's currently available. It's normally the bot has a certain amount of access control, like it wouldn't respond to someone who isn't an administrator. Codes can only be issued to users who are in the recipients list. But for the purposes of this demo, basically all of those access privileges have been disabled. So you can just go ahead and you are essentially an admin if you message the bot. Like I said, please don't use it to send a bunch of codes to somebody who doesn't want it or anything like that. But this will be available for the next hour or so. Like it said in the video, also all of the code, also instructions for setting this up are all in on GitHub and at github.com/throneless-tech/Ionosphere is basically the repository that contains the top level directions for setting up all of this stuff. Yeah, thank you. I think you're muted.
Indeed, I was muted. So time for some questions. And as a reminder, the only way you can ask questions of our great presenters is through the live stream Q&A channel in our exclusive Matrix chat. So one pretty straightforward question. Do you have an URL for that Signal add-on?
Oh, for the whole thing? Well, like I said, the code for the bot, so Ionosphere as a project includes a number of different repositories. You can get the links to all of the repositories along with the instructions on how to set up the whole thing, and where you can file issues and things like that, all at github.com/throneless-tech/Ionosphere is the sort of top level repository with all of the instructions for how to set that up, including instructions for how to set it up standalone, using Docker or on Heroku.
Okay. Well, some audience members have expressed concern over the anonymity guarantees of Ionosphere. Could you talk a little bit about that?
Sure. I mean, kind of like it's said in the video, inherently a bot like this is a person in the middle it is a relay that sits in the middle between the operator of the bot and any users who are receiving messages. So I want to make absolutely clear that messages are end-to-end encrypted to the bot and from the bot to whoever else that message may be going to, but the bot has access to the content of the message. So an operator, so an instance of this bot is only as trusted as the operator that is the admin who's running it and the system that that bot is running on. However, we felt that there were enough use cases where it was useful to either have like an automated way to be able to send different kinds of messages and notifications through a secure channel like Signal, or where there were other security concerns about the sort of possibility of socially engineering Signal groups where you're in a Signal group and you have access to everybody else's phone number. That was still useful to have this bot, but it is only as trusted as the administrator of the bot. Another thing to make clear is that all of the that whoever is using the library for that underpins the bot or is operating an instance of the bot has a lot of latitude for how the state and keys for the bot are stored. The library is set up in such a way that you can implement your own storage interface for all of that state very easily. And then for the bot particularly, it implements a version of that storage interface that uses Qbot's own abstraction interface for storage, so you can store it in any kind of database that you want. So there are a lot of options for being able to store it in encrypted databases, secure key rings. I obviously would advocate running a system that is encrypted at rest, things like that. But it definitely, that was a very long way of saying it's only as trusted as the person who's running the bot, and that's absolutely true.
What has your experience been training managers to use this interface?
Well, Sarah is one of the people that I've worked with and using this interface. I mean, we've engaged with so currently it's a small group of people who are using the interface for this, for the VPN stuff specifically. The technology underpinning the bot has also been used in some other projects, most notably Guardian Project has written a project called, a platform called Sigilrio for basically wrapping a REST API around the Signal library in order to be able to integrate with other platforms, in particular like ticketing systems and things like that for sending out notifications. For training for this particular thing, it's largely been kind of like an experimental process of working to iron out the bugs and do like more lately with the design flowchart and stuff, we've started focusing more on changing the interaction workflow to be something a little bit more approachable than something that's like a more this currently is more of a structured command line like interface rather than having a conversation. And so we're moving in the direction of like having more of a conversation. And it's been very helpful working with Cade at New Design Congress and the folks at Simply Secure to kind of design, like help do the those interviews and like interaction stuff in order to like come up with new design stuff for that has been based on feedback from training people to use this this bot. Sorry, I talked a lot there, Sarah, if you want.
No, I mean, it's exactly what I was going to say. Just we're basically in the phase right now of focusing on the more on the UX and UI with a lot of privacy and security considerations as well, kind of like how we talked about it on the talk. And so Simply Secure and Cade have been really, really helpful in making this happen.
Okay. So one of the concerns that folks have been pointing out in the chat is the Signal pin situation. Do you have any plans on implementing recovery pin for the signals, for the server signals instance? Do you have any idea how that new secure value recovery will affect your code base? And, or perhaps do you have a workaround for that whole pin issue?
Well, currently I mean, we don't currently have a workaround for it or anything like that. Currently the code base is based on a version of the library ported from the Signal desktop client. And it's from a version that was a little bit before they made the pins mandatory. The kind of around the same time, they've ported that whole library part from JavaScript to TypeScript. So that's a little bit more of a lift to update it. And so I think at that time, we'll be figuring out exactly how we want to manage the recovery pin stuff. I mean, I will say too, like one thing that I really want to implement is like right now, from a developer standpoint, it provides a lot of flexibility for things like storing information securely there. But I would really like to be able to provide some best practice stuff for being able to provide like encrypted keyring things and being able to provide support for pins other than just relying on developers to implement it themselves. So I'll definitely be like looking into that for future versions and how to integrate that with like a more secure key storage thing that can be provided out of the box.
Okay, and I do have one last question, and this one perhaps for Sarah. The Libby Liu keynote talked about OTF's current challenges. Have these impacted the project yet, or do you expect them to?
Yeah, that's a great question. And if folks did not manage to catch Libby's keynote, I would definitely highly encourage everyone to watch it. It was truly fantastic, and she gave a really good background on everything that's happening. Yes, unfortunately, it is affecting this project as well. I had to tell Josh this week essentially to pause work on everything because our funds are being essentially held hostage at this point, and we don't have access to them. So that impacts basically all of our projects, all of our active projects, including this one. With that said, I would highly encourage folks to check out Open Collective. A lot of members from this community, like the Internet Freedom community, folks are focused at the intersection of human rights and technology, have kind of gathered together and rallied around essentially supporting each other and supporting all the projects that have been affected by this. And they've created a page on Open Collective, and the link, I believe, is opencollective.com/save Internet Freedom Fund. And if you go there, you can get a bit more information on donating and supporting projects, basically, as in parallel, the OTF team is still trying to work as hard as possible, essentially on getting back on our feet, considering everything that's going on our side of things and the impacts that it's having on projects and deeply affecting people. So yes, unfortunately, this is one of them that we're going to have to pause for the moment. But the good thing is that code is available in public and open source, and that's the beauty of open source projects that we have. So anyone that wants to jump in there and contribute and work with Josh can definitely do that.
Okay, well, So obviously there's still a lot of conversation that we still have going on in the Matrix chat. If you'd like to go into our hallway conversations channel to follow up with some of them, we'd like to invite you and attendees to do so. Sarah Aoun, Josh King, thank you very much for joining us at Hope 2020.
Thank you all.
Thanks so much.